Good afternoon, ladies and gentlemen. Welcome to Tech Gig Webinars, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Today's session is first in the webinar series on business intelligence, giving insights into predictive analytics. We are delighted to have Mr. Avik Sarkar with us today. Mr. Avik is architect in predictive analytics and data mining at IBM. His job engages him to work on developing predictive analytics-based industry assets. He has over 10 years of enormous experience in the areas of predictive analytics, data mining, text mining, statistical modeling, and related areas across verticals like telecommunication, retail, high-tech, environment, insurance, and economic forecasting. Avik is an avid speaker in public forums, and based on his knowledge, enthusiasm, and experience, he is eminently qualified to speak to us today about predictive analytics. Gentlemen, this presentation will continue for next 1 hour, and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Avik.
Thank you for introducing me. Can everyone listen to me? Hello, how are you doing? Can you listen to me? Type in there and
Yes, Avik, we can hear you. You can go ahead with the presentation.
okay, that sounds good. Also, let me know if you can see the screen on my computer.
Yes, we can see the screen. You can be a bit louder.
Yes, so a bit louder. So let me know at any point in time if you become feeble, so I can become loud, and that's what I'll say.
Okay, right. Thank you.
So today's webinar, we see a lot of buzz around analytics and predictive analytics. People talking about analytics, people talking about Smarter Planet. So all of you would have seen the Smarter Planet ads on TV that comes from IBM side, about some traffic signals, some babies in a neonatal clinic, and all those ads from Smarter Planet of IBM. So what drives Smarter Planet is basically analytics at the back end. So there is a lot of conception and misconception about analytics, what it can do and what it cannot do. So this first Tech Gig forum in this BI series will give you an overview about the various types of analytics that is possible in today's domain, and also the various tools that are available for the same. And then giving you an overview about business analytics, I will delve deeper into predictive analytics, which is one sub-area of business analytics per se. So predictive analytics is also commonly known as data mining in the technical community. So I'll give you an overview about the data mining processes and overview of some of the data mining tools. So this gives an overview of the talk that I will be following today. So I'll start with giving you an overview about business analytics, the different types of analytics. Then give you an overview of predictive analytics tools and processes. And then I will touch upon a bit on the algorithms that are available for predictive analytics. So the algorithm part is a very technical and mathematical in nature, so I will just touch upon that, and if people are interested, then they can read and refer that at their own time. So the primarily parts of the talk will be around introduction to business analytics and introduction to predictive analytics. And the third section that you see will be very short. So I will start with it.
Avik, we are receiving feedback saying that the voice was not clear. Can you be a little near to the mic while speaking?
Yes, I am quite near to the mic. It's
okay.
on my so So can you guys listen to me now?
Now we can listen a bit clear.
Okay. So just let me know if any point I'm feeble. I'll also try to remember and be loud.
Sure. Right. Thank you.
Also. So one of the biggest challenges in today's world is to bridge the information gap. So on one end we have huge amounts of information available today in today's world, and then how do we make use of this information to make it beneficial for our needs is one of the biggest questions that all the enterprises and companies are facing in today's date. How do we bridge the gaps? There might be petabytes and terabytes of data lying in your computer. How do you use them? How do you use your past transaction record? How do you use your customer information to improve your business? So this is one of the biggest challenges in today's world. And there was a recent study done in 2009 by the CIO study of the CIOs, and we asked them what was one of their dying problems, and they told that information management and having a coherent information management strategy in place was one of the biggest challenges of all the CIOs that were involved in the study done. And as you can see, that this is one of the biggest challenges today. And why are we there on a huge amounts of data? So I'll give you a bit of a background. So this slide is a bit is just an interesting slide, but it takes you back to the 80s when the IT revolution was starting. So today in India we see a lot of IT companies, and then also in worldwide there are a lot of IT companies. The IT revolution has actually started in the mid-80s, in the 70s and 60s in the US, and it had got pace. And then what has happened as a result of the IT revolution? Traditionally, businesses were happening on paper. So like you go to a retail store, whatever you buy will be written down by the shopkeeper on paper, and then that bill is given to you. So as a result of IT and automation, what has happened is that this thing is now becoming digitized. So all of the billing is still in the is happening in the digitized format, and the data is being stored in backend database or some flat file per se. So this is what we have achieved because of the IT revolution over the last few years, per se. And what has the IT revolution led to? This IT revolution has led to the generation of huge volumes of data over the years. So now the companies who have started automating maybe say 5 years, 10 years back, they are sitting on huge volumes of data at their data warehouse and other service. And now they want to use this data to get the next edge, next competitive edge. Like if everyone else is doing the same thing, how do you get the next competitive edge? By using the data, by finding the insights from the data, because the data contains a lot of information and a lot of insights. And business analytics is exactly suited for that need. It solves this problem for you. So business analytics comes in handy exactly at this point. When you have huge volumes of data, it helps you understand the pattern, and it helps you understand and drive business decisions efficiently and in a smart manner based on that. And this data web that you see, the black line on the right, the data web has started some time back. So there are companies like Google and Microsoft and the Yahoo of the world whose primary business is around data, and they have already started on the data web. And then this data web is doing analytics in a enterprise scenario is becoming more and more popular in the other companies. And we predict that this web is going to be there for the next 20-30 years to come. This data and the real-time advanced analytics web. And this is a very good time that we are engaging in advanced analytics and business analytics. So now, in the next slide, I'll just give you one overview. It's not new that for us to do business analytics. Like banks and financial institutions have been doing analytics for pretty much long time. But then, what was the challenges? The challenges still remain the same, as you can see on the left.
Avik, Avik, sorry to disturb you again. People are unable to see your slide change. Actually, they were stuck with the first slide only.
So what do I have to do with that?
You can just click. You can come out of the full view of the presentation once.
Yeah. So do you think the full view of the presentation is bad?
No. Actually, because even I am seeing the first slide only, not the slide which is ahead of it.
Oh, so what do I do for that? I stop and share again,
Just 1 second.
or anything has to be done from your end?
No. Right. Just now I have taken back the control and I'm giving the control once again to you.
Okay.
You got a request to change, share your screen.
Yes, I have already shared my screen, so I will keep this view also open so that I can see what's happening there.
Sure.
So this
Slide
was the
now.
slide that I was talking about.
Right. We can see your slide now.
Yes. But now when I've gone to full screen mode, can you see now? So this was the slide I was talking about. So and I was talking about around this for a couple of minutes. So what has happened is that we were on a data on automation wave in the last 20 years, 30 years. And that has led to a lot of data being generated. And as a result of this, companies are sitting on huge volumes of data. The next competitive advantage comes to the corporates by making the best use of this data. And that is where the business analytics web is starting today. And we are in a very good phase to engage on this journey of business analytics. So I have changed the slide, but I don't see it being updated on the audience view. Yes, it is updated. So it actually shows me a counter that with the view being updated. So what I was telling, I was on this slide. So you can see on the left there is a lack of insight, and what are the challenges in the information challenges that we spoke about? Inability to predict, inefficient access, velocity of data. And then what has happened is that analytics has been there, and this was primarily been done by the insurance companies, the finance companies, and the banks. They have been doing analytics for pretty much a long time. But what was that primarily the data used to be in a transactional database, and there the data would be uploaded into some Excel file or some flat file and give it to analysts at the back end. The analysts will work on it for a few months and then deliver the analytics. And by the time they deliver these results to the business has moved on. The business has moved on and then we have gone further ahead. So what has happened is that there is a delay happening in this space. So doing delay is something that we cannot afford to have in today's world. So in today's world, we want real-time analytics today. And for this reason, we are suggesting a breakaway approach. So real-time breakaway approach to predict and act, and not just something that analysts can do, but something that everyone can do, and something at the point of impact. Yes. So something at the point of impact. And so these are the things of the breakaway approach. And how we achieve this is based on some of the tools that I will discuss during this session. So going to my next slide, yes, it started updating. Now, so now I will actually talk to you about the various types of analytics. So when you hear about business analytics per se, you hear various buzzwords like reporting, dashboard, clustering, classification, optimization, web analytics, marketing campaigns, and simulation, what if analysis. So how do they do this all bind in together? So and then you also see like content analytics, text mining. How do all this binding together? So this slide gives you an overview of that. and then I will take you to one of each of these types of analytics. So here I have described the different types of analytics that are around today. So this is not a world view, but this is an IBM view of how we see the different analytics being present there and how we classify them. So we first descriptive analytics as the first pillar, and on the left we have the structured and unstructured data coming in. Then we have predictive analytics. Then we have something called prescriptive analytics, and then we have content analytics and web analytics on the right. So I will go to each one of these and try to explain what each of these are. So I have gone to the next slide, and hopefully it will update. Yes, it started updating this slide. The first slide is about prescriptive analytics, or what we call as business intelligence. So say you have doing sales in your region for the last 10 years, and you want to do querying and reporting on that data. You want to see how the sales figure has been over the last 10 years. You want to analyze the sales figures across geography, across region, across sales manager. So you can do all these sort of things. And this sort of analytics of business intelligence, it helps you answer the questions like how are we doing? Are we on track or not? And some of the tools in the PI, as you call it, the business intelligence world, are like dashboarding, scorecarding, reporting, querying, analysis, planning. And the IBM tool for doing this is the Cognos software, like IBM Cognos software that is available. Now coming to the next one is that as you saw, there is a transactional data lying at the bottom. So that is what I mean by SQL. And on top of the transactional data, I have the business intelligence layer. So what the business intelligence layer is doing is it's taking all the data, creating some cubes on top of the data, and then doing some reporting on the data. So if you have sales figures from say 2000 to 2010, it will show you different trend charts. It will show you different reports based on by salesman, by region, by geography, and whatever you request it to do. But now, based on this data, if you want to extrapolate and if you want to forecast data, like what will be the expected sales from 2011 to 2015, that is where we cannot use descriptive statistics for, and for that we have to use predictive analytics per se. And this talk is primarily about predictive analytics. So we have some historical data. Based on the historical data, learn the patterns and apply it on the unknown data. So this is basically the crux of predictive analytics. And this slide gives you an overview of that. And in the IBM world, the predictive analytics tool that we have is, I have changed the slide, it's not getting it. Yes. So the slide is it just started to update. It's just 1%. Yes, updating now. So in the IBM world, we do it using three things. First, understand what is happening in your business, then predict, and then act. So we have the three-layer thing: understand, predict, and act. And this is the crux of predictive analytics. So we will go deeper into predictive analytics after we have covered up all the types of analytics in the later phase. So for predictive analytics per se, we have the tool that is SPSS. So you can see that on the top right. The next one that we have is called prescriptive analytics. So the slide is just starting to update. In prescriptive analytics, this is more relevant for industrial settings or manufacturing scenarios. And for prescriptive analytics, what we do is we basically do some optimization, linear optimization, non-linear optimization. So you have various inputs. Say say you have a cotton mill that manufactures 100 items of shirts, and now for Diwali you have got order for 2,000 units of shirts. Now, what are the variables that you need to change to meet that demand. So this is the type of problem that you need to solve. For that, you need to use something that is called as optimization. And the optimization engine that belongs to IBM is called iLog. On the top right, you can see that. And this is primarily about the structured data. So in a recent study that was done for organizations, we have seen that structured data is like structured data is the type of data that stays in your database in a regular form. So it's mostly numerical data. It's not numerical or some fixed value data, like it can be a name of a city or a town or some person name, is what we mean by structured data. When moving from structured data to unstructured data, organizations primary data that is stored in the organization is unstructured data. So unstructured data is basically the ocean. So you can see on the right, if you compare the percentage of structured data to the percentage of unstructured data, the unstructured data combines about 60 to 90% of the data lying within an enterprise. And all these types of analytics that I spoke about till this time, Cognos or SPSS for doing business intelligence or predictive analytics, they can do early analytics on structured data. So how do we break this barrier and get insights from the unstructured data? So we have different tools for that. So now consider this example. I've gone to the next slide. It's updating slowly. So we have something called a content analytics, and we have a case that a police officer has written, like a certain suspect is identified as John and matches the description of the crime. So it's basically FIR data that the police officer has written there. So it's a unstructured data. So we can use the various content analysis tool to transform this unstructured data to a structured data. So you can see on the top right, what has happened is that this unstructured data, using the tools like SPSS, is transformed into a structured format. So various entities from this data, like what is the name of the criminal, what is the type of crime, what is the location of crime, what is the type of crime, and all these are extracted automatically from the data. And based on that, what we can do is that we can now put this data into a database, and we can apply a traditional analytics like business intelligence and prediction based on top of this. So whatever unstructured data that was lying can also be used now for your analysis and for getting some value out of it. So content analytics primarily deals with data that is lying within the organization, and then outside the organization there is a lot of data. And in today's world, there is a lot of data on places like Twitter, Facebook, and things like that. So every company, a lot of the companies these days have their Facebook page, and their customers are coming in and writing comments about them. Twitter feeds and Twitter handles are very popular. So if you want to monitor what is the buzz of a certain topic, then you can view something that is called a semantic analysis. And semantic analysis helps you to fetch data from the web, analyze them, and do all the extraction and do all the analytics on top of it, and give you nice reports. So one of the reports that you can see is a trend chart that gives you that you can see below is a trend chart of the topic. So how are the topics evolving over time? What are the topics telling? Is the people's sentiment about this topic positive or negative? You can do various types of analytics on top of this, and this basically goes to the semantic analytics domain, or sentiment analysis is very specific one use case of this. And the IBM tools for doing this are Cognos and SPSS. So there are various tools in Cognos, like Cognos Consumer Insight and SPSS Text Mining, that helps us do this sort of analytics. Now going to the next slide. Now what happens is, now consider the scenario, we have considered a lot of analytics. Now say you are in a retail online store like Amazon or eBay, and you are doing a lot of click-through, and you are doing a lot of activities on the site. How can all these activities that the customer is doing on the site be utilized to target analytics towards you? So that comes under what we call as web analytics. So web analytics captures the user's online behavior and this rich data, like what is the type of search that you're building, what are the type of websites you're building, and all this information that you have within a website, outside a website, can be used to understand the customer better and to target better analytics towards the customer. And then you can also do marketing campaigns on the customers. Like for marketing campaigns, what we have in marketing analytics, like how do you launch a marketing campaign, what is the target for a marketing campaign, and what is the various variables, what is the profit, what is the spend you want from this marketing campaign. So there's a whole world of marketing campaigns here, and for that, Unica is the product that helps us do that. For the web analytics part, Core Metrics is the product at IBM that helps us do this analytics. So this basically covers a lot of the analytics. Now, one area of analytics that is also quite popular that doesn't fall in this classification is the analytics of simulation. So in simulation, say you look at the bottom left, what you have is that, say you have a certain scenario, say a sales price, the volume of sales leading to something that is called a cash inflow, and then based on that you are calculating the net cash flow and the profit. So you have the different variables that are given to you, and you want to do a what-if simulation on this. And this is a very popular type of analytics that is often done by companies, and this falls under the arena of Monte Carlo simulation. And there are a lot of tools that are listed here on the right that helps us do some of these Monte Carlo simulation, like risk, crystal ball, SPSS statistics can do some of these, and model risk and risk solver. So what I have done in this session is I have walked you through the different types of analytics and what each type of analytics does. So if you are new to the analytics domain and you want to learn one of these tools, you need to first understand what is your type or what is your expertise or what is your liking in one of these. Also, if you're an enterprise, you want to apply analytics to your data, you have to first understand what is your problem statement within the enterprise and what is the exact type of analytics that suits you. Like if you want to do some sort of, if you're an online retail store, you want to do possibly web analytics rather than doing something like descriptive analytics optimization, which is more suited for a manufacturing industry. So this sort of understanding about analytics gives you a whole spectrum of the various analytics this slide gives you, and what are the tools that are available. And these tools are primarily the tools that are available from IBM. Outside IBM, you'll find a lot of competitor tools also available for each one of them. So this basically brings me to the end of the first section of my talk that gives an overview on business analytics. And I'll then go to the next. So, Bharat, shall we stop for some time and do some questions? Or
I have already shared a couple of questions with you. You can continue, or you can continue with the questions which you received so far.
Okay. Yes. Yes. Just try to see that. Which is the most best BI tool to survive in coming days? Okay. I think that's more of a, I know about the tools that are there at IBM, like from BI perspective, Cognos is a tool, and I know about a lot of other tools. I think from Oracle, SAP, there are a lot of tools, but I have not used many of them, so I'll not be in the best position to comment on that. I've used Cognos a lot. I think it's one of the best in the industry. Next question, basic understanding to non-BI guys. Okay. How can we use predictive analytics in service industry? So I think if you have a more specific use case, you can write to me about what it would be, and then we can answer based on that. My question is in a stream of business analytics, you will have to use all the software like Cognos, iLog. Yes, you're exactly correct. So when we build industry solutions, so we talk about business analytics, and in a lot of the solutions, what happens is that the customer first wants to see what has happened in the past. So that is done using the business intelligence tool, Cognos, and then he wants to see the prediction, and that prediction is then given based on SPSS. So and then based on what the needs are, we have to integrate. So all these tools that I've spoken about, they all integrate well with each other, and then you can always have a continuous flow and one software that goes to the customer. So relate predictive analytics to market research. So for market research particularly, there are a lot of tools for predictive analytics. So there is one called SPSS data collection that helps you collect data for market research, and then there is a complex sample in SPSS that helps you to collect samples from data, plan your market research study, and then do the analysis based on the market research. I think I'll just go to the slide because I've taken I think 4 or 5 questions. I think rest we can take at the end of the session. Just fine, Bharat?
You can go ahead with the presentation.
So yes, so just waiting for the update. Just updating now. So I'll talk a bit about data mining process or predictive analytics process, and this is something that comes as the best as a guide to be followed for doing data mining. So this came as a standard process for doing data mining. In the late 90s, this came up with Daimler, SPSS, and NCR, where these 3 bodies came up with this process. And this is called as a CRISP-DM, as you can see, cross-industry standard process for data mining. It basically is a framework for recording your experience. It's more like a project management framework for data mining. And it's advisable for people doing data mining for the first time to follow this so that they can get the maximum ROI on their spend. And they can get the best benefit out of it. That is what the aim of this framework is. Now, coming to the next slide, which I guess would be updated soon. Coming to the next slide, this gives you the various steps on the CRISP-DM data mining. So the various steps in CRISP data mining are first starting with the business understanding. So say you are a bank and you have your data on customers. Now what is it you want to do? You want to group your customers based on the geography. That can be one objective, or you can also group your customers based on how much they spend and then do a marketing campaign based on that. So you can decide, okay, now I'm working on a marketing campaign only in the Delhi region. That can be one objective, business understanding. Other objective can be, okay, I want to do a campaign only for the high value customers who are spending say more than 10 lakhs or so in a year. So you have to first define your business objective before you start on doing some predictive analytics study, because that is more very important. Often when we start to do predictive analytics, we see that all the required variables or information that are required for doing analysis are not present or not being collected. Then what happens is that you have to go and actually collect some data for doing the analysis. So if you want to say do the analysis of the customers, high value analysis, or if you want to, and then you see that, if it is known that for doing the customer high value analysis, it's good to know what their income level are and what is the type of their education qualification, what is the type of their family. So these are like some of the basic information. Then as a part of the data understanding, what you will do is that you have to go back and collect some of this data. So you need not collect all of this data. You can possibly do some sampling and collect some of this data and extrapolate it. And then the third step comes with the data preparation. So data preparation comes with, suppose you are collecting call record data for a telecom company. So the input data that is stored in your database is say the number how is the call was made, the number 2 is the call was made, and then what was the duration of the call. Now you have to summarize this data into a customer word line where you tell, okay, this is the customer number A, customer name A, B, and this customer has made so many local calls, so many STD calls, so many ISD calls. So you have to transform the data from its raw form to be to a form that will be suited for analysis. So this comes under the data preparation steps. Then comes the modeling phase. In the modeling phase, you actually apply some of the predictive algorithms that we will talk about in the third part. The predictive algorithm will tell you, okay, what is the need of the analysis and what is the different thing that you want to do. And there you use the tools like SPSS that has a collection of algorithms, and you can apply them on the historic data. And once you have applied some of the algorithms, you have to first evaluate that algorithm. You have to evaluate the algorithm and see how good your predictions are. Only when you are satisfied that your predictions are good enough, then you go ahead and deploy the solution in the real life scenario. So what you see in the next step, next slide is the different steps that I just spoke about: business understanding, data preparation, modeling, evaluation, and deployment. So what are the various steps that are there in each of these? So in business understanding, there is like determine what the business objectives are. In data preparation, often what happens is that you have a lot of data cleaning issues, like you have a lot of data quality issues, like a lot of data cleaning issues. So all this have to be done. And then in the modeling techniques, you have to like what I suggest you do is that you go ahead and read on CRISP-DM. That will give you a better idea on how you can do this and apply it for your scenario. So this gives an overview of the predictive enterprise. So like what I mean by predictive enterprise is it's a customer is buying something or renewing something, or is claiming an insurance or cancelling something, and then there is a business process in between. The business process helps us to determine whether the customer is doing something is correct or not. Like, is he doing a fraud? Is he doing some claims processing or a customer support? And then on the right, you have the analytics coming in. Then you have the data coming in from different layers. As I told you, the different historic data is there in your database coming from bottom, and this data is based on the different analytics that you're doing in between. This analytics then helps you to deliver the value to this data. So this gives you an overview about the steps you follow in an enterprise to get the best value out of analytics. And then customer feedback is also so this gives you an overview about the process that one needs to follow in the predictive analytics world. So this process needs to be followed if you are coming into a new predictive analytics project. And now I will talk a bit about the predictive analytics tools. And the tool that I will be talking about primarily is IBM SPSS. There was a recent study done by Hewitts and Associates in 2001, and they have come with the Hewitts Victory Index, where they have plotted the different analytics, predictive analytic vendors on operation versus viability of the company. And in that index, IBM SPSS has come on the top. So you can also note down the other competitors or the other players in this space of predictive analytics. They are like SAS, Pegasus Software, StatSoft. There's also something that SAP has started. And then there are some other vendors in the market which are open source, like R or Veta, which is not included in this survey because they are open source and free. So they are also quite good for doing predictive analytics. So the software that I will be talking about in the rest of this talk, it will be IBM SPSS software. So I will give you a brief overview about the 4 pillars in the IBM SPSS software, and these 4 pillars are primarily the data collection. The data collection, as you understand, is more for collecting data from surveys. So if you want to do a survey of the population, or if you want to do a market research study, this sort of data collection comes in very handy, because you have to first define your population, and your population may be the whole city of Delhi. Now you want to understand some of the behavior of the people of Delhi, and that may include, say, maybe 20 million people. You cannot go to every 20 million people and ask them a question. For that, you need to intelligently divide your population and go and do the survey only from a small group, say of 1,000 or 2,000 people, and then based on that you do the prediction. And this you see a lot happening during the elections, where election forecasts come in. So people will do some exit poll on a small set of people, and then use that result to extrapolate what the result will be for the whole population. So a data collection software of SPSS helps for that sort of analysis. Then the next and then you have the next, then you have the next software, that is the SPSS statistics, which helps in doing a lot of the statistical analysis per se. So if you have a small population and if you want to understand, if you have a small sample of data and using that sample of data, you want to understand about the whole population, SPSS statistics is a software for your purpose. Then if you want to do some predictive modeling per se, something like understand a customer churn or customer lifetime value, or do some classification or clustering, for that SPSS modeler is the best suited software. If you want to do some analytics on unstructured data, for that SPSS text analytics, because I was telling you, like if you have a block of text and you want to extract information from the text, SPSS text analytics will become very handy there. Now, what happens is that, as I told you, that in SPM, you can do all this analysis in one standard of machine or analyst. The analyst at the end of analysis comes out with a model, and this model is then deployed for the whole enterprise. And for deployment, you need some IT tools to deploy it and for various people to use it. So SPSS has a range of tools in that area, which is called collaboration and deployment services, that helps in deployment. And then how do the business user use it? So say, based on the customer profile, this customer needs to be given 10% discount. Now, in a certain store, a retail store, the store manager will know, okay, on what product I want to give this discount. So a store manager in Bangalore might give a very different discount than a store manager in Delhi, based on that. So to take the input from predictive analytics and to apply the business layer on top of it, this can be possible using the SPSS decision management tool. So you can go into each of these tools into details and understand it. So I will give you an overview on how we can do data mining based on historical data and how that is possible in today's date. So say we start with some historical data to develop a predictive model. So the historical data is first divided into a training set and a validation set. So, and then based on the training set on the left, we do a training process. And for training process, what is done is that some algorithm is applied. And because of the application of the algorithm, what happens based on this training data? So what we have data is that we have data on like what is the profile of the customer and the customer who has churned out, maybe in a telecom scenario. Now, based on historic data, we do a training process, and at the end of a training process, what we come up with is a model, and then this model is applied for the unknown data set or the new data set. Now, after the training process is over, this model is used for scoring in the real life scenario based on the validation data set or on the real data set, as you can see. So in this case, you have the customer profile, but you don't know whether the customer is likely to churn or not. So based on the profile, you are using predictive analytics to predict based on this profile and the usage of the customer whether the customer is likely to churn out from the service or not. And this gives you the next slide gives you overview where you are using SPSS to do predictive analytics when you have structured data along with some unstructured data. So you have you've done a structured data preparation and you have got some of the customer variables. So you have the emails per day, the net speed of the broadband, some of the things that you have got as a response from a survey. There are some response from a survey which are in the form of raw text, say a paragraph. So what we can do is that using SPSS text mining, this text mining will extract the concept from the text and it will actually create more columns of this concept. And then this becomes a structured data that can be used for predictive analytics. So you are using your historic data and you are using your structured data and combining the two together to come up with an overall analysis. And then you can do the same training process that I showed you before and then come up with a model and do the model scoring. So this next slide shows you analytical topology or gives you a reference diagram. So you have the data coming at the bottom. On top of it, you have the different data mining that's happening in the gray and in the green at the bottom. So you have the business intelligence also happening as a parallel layer. And then you have the different type of things that you want to do. So you might want to do a segmentation modeling, you might want to do a propensity modeling or a lifetime value of the customer, risk propensity profiling, or active term data analysis. And then you have the different channels that when you deliver these analytics results. You also need a channel to deliver these analytics results. So I'll just give you some real life examples. And now that I have spoken about the analytics process, I'll give you some real life examples about how these are applied. So for some of this, the first one is where a physician uses this analytics. I think yes, on the screen around here now. So this is an ad that comes for IBM Smart Planet. You can see this has been implemented in a hospital in the US, where in the neonatal ward, where babies who are born are in critical state, every sensor or every movement from the baby is recorded. And what is done is that there are a lot of sensors attached on the baby's body, and these sensors send in data to a central server in that hospital. And then based on that data collected, what happens is that the doctor can monitor what the status of the baby is. And if something critical is happening, it will send the alarm to the physician so that the physician can come in and attend to it. So this is a premature baby where the physician is using predictive analytics based on the sensors from the baby's body to come up with decisions. Now we have another loan officer. So a loan officer is, say, a bank manager to whom a customer comes and applies server. The loan officer inserts all the customer details into the system, and there is already a previously existing model of that tells, okay, based on this demographic profile and this based on this credit rating, you should give a customer this much amount of loan, and this should be the interest rate. Based on the profile of the customer, the loan officer can decide how much loan to give and what should be the rate of that loan. Again, think of a retail sales associate where you are coming to a billing counter in, say, one of the stores like Reliance Fresh or in Big Bazaar, and when you come to a retail counter, based on what you have bought, the the counter guy is looking at your past transactions and giving you some offers. And all these are happening in real time. In the fourth example, what is happening is that a telco call center representative is getting a call from a customer, and then he is using the analytics to give offers to the customer. So I have a sample screen for. So we have actually applications for all of this built at IBM. So I have a sample screen for this telco thing that I'm talking about. I'll just wait for it to get updated. So what you can see on this screen is that the bottom part where it tells customer details, you have 3 tabs there: summary, user research, recharge, and the case detail. So that is what we call the traditional call center. So you call into a call center, so you have the call, you enter the customer's phone number on the top. This is the agent's call center screen. So when you call a call center, you get all these details to you. So you have the customer summary available, you have the usage and the recharge data available, and you have the case detail, like what are the previous cases that are open for this customer. This is the traditional part. Now on top of this, what we have done is that we have 3 dials on the top of the screen. And what these dials are doing is that this is looking at the customer's previous history and telling whether the customer is likely to churn or not, and that is the propensity to churn. The first dial that you see is the propensity to churn. And it tells me that the customer is active and is not a very high propensity to churn. The next dial gives me the customer satisfaction score, like how satisfied the customer is. So that's the medium dial that gives that. And the third dial on the right gives me the customer's lifetime value. So is it a low value customer, high value customer, or a medium value customer? So this customer comes in as a high value customer. So you see the traditional telco screen below, and then you have the analytics front end coming on the top, where you have some of the inputs coming from the analytics engine and actually doing this on the fly. And then based on that, on this customer profile, the call center agent can actually give some offers on the left. As you can see, there is 10% off on phones and some SMS package, and all these are coming in real time. So the moment the customer logs in, all this data comes in, and this is not pre-computed. This happens all on the fly using all the SPSS and Cognos tools that I am talking about. All this can happen on the fly. And then on the left part, so I couldn't show you a live demo, but on the left part, there is add comments to open case. So when a call center agent actually enters some text and do a save, the dials on the top will change automatically. And if the customer is very unhappy with the service, the customer will get some lucrative offers, and these lucrative offers are to retain the customer and so that he doesn't lose the service. So this is all what I was telling, the real-time analytics, and analytics actually finger steps. So all the analytics happening at the back end. And this is what we have as like a smart call center of tomorrow, where you are not only just responding to the query of the customer, but you can actually see all the customer profile from an analytics viewpoint and determine how valuable the customers are, and then suggest things to the customer. Now going to the next slide, it gives you an overview about the various areas. If you are in a company and you are handling a certain role in your organization, it basically classifies your organization into 3 areas, like financial areas, customer performance areas, or operational performance areas, and you can apply analytics for each of these. For each of these, IBM has some solution or some ready solution. Like I showed you the solution for telco. We have several such solutions built from the analytics perspective, fine-tuned to your need, that you can just come in and use. So if you have a need for any of these, you can get in. You can use one of these in your organization. Now, this brings me to the end of the next section. I think I have only 5 minutes left, so I'll just walk you quickly through the predictive analytics techniques and algorithms. So when you talk about predictive analytics, there are a lot of things that come up as buzzwords, and some of these buzzwords are like classification, clustering and segmentation, statistical modeling, factor analysis, and social network analysis. So I will give you some of the examples. Like if you want to use one of these tools like SPSS, you need to know how does your problem statement break up into one of these. So if you are, is the customer likely to churn? Will the customer buy the certain product? So this is the type of question a business problem that you want to answer. Classification techniques is the type of technique that you want to use. If you want to answer the type of question like the customers based on similar voice usage pattern, you want to group the customers, or if you are a product company and you want to group the similar products based on usage pattern or geography of use, you need to use some sort of technique like a clustering or segmentation. If you want to predict the product sales trends over the past few years or the new customer subscription trend over the last few months, what you can use something called statistical modeling, forecasting, time series analysis, multivariate analysis, and there are a range of techniques that lies in this area. Now, you can use something called a factor analysis that helps you to understand the important variables from the data, and it helps you in answering questions: what are the factors that leads to the customer to churn? So you can help and rectify those factors. What are the key factors behind the customer behind the success or failure of a product? So factor analysis helps you answer these questions. Now coming to the last and the new type of analytics, that is the social network analysis. It helps you define relationship between entities and then exploit this relationship for the next level of valuable information. The next few slides that I have are pretty technical in nature. So this slide basically gives you some of the names of the algorithm that I spoke about. So in the previous slide, I spoke about the classification of the technologies, like classification technologies or the clustering technologies. Can I give you some of the names of the algorithms of the actual techniques that does it? So in classification, we have say something like neural network or decision tree or k-nearest neighbor, support vector machine. For clustering, you have say k-means clustering, hierarchical clustering, or cell organizing map. And then we have some of these algorithms at the bottom, which are like text mining, social network analysis, association mining, rule assessment, and things like that. I'll give you a sneak peek into one of the very popular algorithm. I saw that there is a separate session on regression completely, but regression is one of the most popular predictive analytics methods. So if you want to say predict the sales of so if you have two primary types of regression, there are many. So basically there are two to start with. So one is the linear regression. So if you want to predict the sales of a certain company based on various inputs like what is the number of employees working and what are the other variables. So what you can do is that you can use this sales as based on historic data with the Y on the left, and then you have the various inputs like the number of employees, input values, and things like that as like x1, x2 are the various input variables. And you learn a linear regression model, and then this linear regression model is used to predict for the unknown data. Again, say if you have if the type of target that you are trying to predict is a probability or a range between a 0 or 1. Say, as I was talking to you, is the customer likely to churn or not? So you have basically a 0 or 1 value or a probability value. In that case, what you use is a logistic regression as shown on the right. So it also takes a very similar form as the linear regression on the left, but you have some exponential based calculation, as you can see in the equation there, and based on that, the value of this function comes out always in the range of 0 to 1. Another very popular technique that is used a lot in predictive analytics is the decision tree. So in decision tree, so if you have a round object, with a simple example on the left, you have a round object and you want to decide whether it's a ball or a clue. So clue is a wool ball per se, and you say whether the object is round, yes or no, and then whether it contains threads. If it tells yes, then it's a clue, otherwise it's a ball. So based on such decisioning at every stage, you actually come to a conclusion, and this is basically the model that is learned by the predictive analytics system during the learning phase. And then for a more complicated in a real life case, you have a lot of other variables on the right, and then things coming up. And then I'll come to the last thing, and this is the last slide. So we have basically social network analysis, so various individuals. So currently in analytics, what we consider is that, say, I and my friend who talk to each other on the phone, say, every day for a 15 minutes or an hour, are considered as independent individuals on whom the prediction is applied. But there is a high chance that if my friend buys a new product, I am also likely to buy it. And now consider two scenarios. Say there is a new model of iPhone that has been launched, and you as an individual, you have say 10 friends, and in the first scenario, out of your 10 friends, only one of your 10 friends have that new model of iPhone. How likely are you to buy that new model of iPhone? And the second scenario, out of your 10 friends, 8 of them have the new model of your iPhone. In the second case, your social network is, since they already have that product, you are more likely to buy that product or adapt that new technology or trend, because your network or social network is forcing you to do that. And this phenomena that works in our mind, okay, now that 8 of my friends have this new model of iPhone, I should be buying it. This psychology and phenomena is modeled in the social network analysis, and based on the network structure and your friends and your connection, prediction is made about an individual. So I have a couple of examples in the next slide. Like if you see like the thing in the yellow is the person who has churned out or adopted a new product, and because of that, this network effect flows in the network, and then people connected to these people are also likely to adapt that new product or churn out from the service. So this is like a word of mouth. So you buy something, you tell your friends to buy it. So this effect from the crowd or from the social network is what is happening in social network analysis. So with that, with that review of social network analysis algorithms, I come to an end of my talk, and now I will open the forum for questions, if any. Yes, Bharat, you are there.
Yes, Avik, already I have shared almost 100 questions to you.
Okay. Okay, yes, I am just opening them. So, yes. So there is a question from, I am just trying to find out where I stopped last time. Yes, I just found it. Cognos and Informatica, how do they differ? I think Cognos is a business intelligence tool. Informatica has the primarily database plus some business intelligence, but Cognos is only a business intelligence tool. But both are from the IBM family, and also in Informatica, it's for like high-end performance tools. So depending on your different size of the application and the size of the requirement, the different tools are suggested. So is SPSS and SAS same? No, as I showed you in that Horitz report, SPSS, SAS, KXCN are all competitors. The tool for predictive analytics that IBM has, it is called SPSS. SAS is one of our largest competitors in that space. So how would you rate SAS? So I cannot do that. I need some Gartner or Forrester or some independent body has to do that. Is there any certification from IBM for Cognos software? Yes, so you can go to the site ibm.com/certify, CERTIFY. So if you go to the ibm.com/certify, so or I can share it to everyone, ibm.com/certify, you can find the various certifications that are available on Cognos, SPSS, and all the other IBM software that you can do. And what is the main motto of BI? What is BI all about? Is it about analyzing data? So BI is basically about you have your historical data and how you can look into your historical data from various perspectives. So do a deeper analysis of your historical data is the main motto of BI, per se. What theoretical background one needs to be in the web analytics expert? So web analytics is basically based on like your click-through data. So click-through data is very much important. So it's more of an IT thing, but then you have a lot of things coming in. Like in Google and Yahoo, you have something that's called as like ads come up. So in ads, you have a lot of economics and game theory that go into how which ad should come on the top and the pricing over there. So some understanding of economics and game theory is helpful for advanced web analytics. So for basic web analytics, I think simple IT knowledge is good enough, along with some predictive tools like SPSS or SAS. How would you rate tools built up on Hadoop based on the concept of MapReduce job for analytics? I know that there are some algorithms that are available on SPSS that are available on Hadoop, but I don't know about any tool that does everything in a parallel environment. Like you have MapReduce or Hadoop, which are internal algorithms by Google or Yahoo, but as a product, I am not aware of any other than SPSS that does some of these things. Interesting presentation. Predictive analytics in procurement. I think please in procurement you can do analytics, but the type of analytics that you want to do, you have to come to fine point description of the type of your need, and then we can possibly suggest you some sort of analytics. Like if you have a problem statement to start with, I can possibly suggest you like what is the type of analytics that you can do based on that. So how about the concept of cubes in SPSS? So cubes is more of a concept in the data warehousing and business intelligence domain. So Cognos has a concept of cubes, and any data warehouse is a concept of cubes. But in SPSS, we take everything in a tabular view, or take anything from a database table and then apply analytics on top of that. So there is no concept of cubes in SPSS per se. The next question is, what kind of data sources can SPSS use to collect data? So SPSS has a lot of data sources that you can collect data from. So starting from a traditional database, and then there are things like flat file and like SPSS proprietary data format. We can also collect data from the proprietary formats like XML or Excel per se. So it actually covers a lot of the files. And if you have your text file, you can define what the delimiters in your text files are, and then based on that, data can be collected from there. What is training set and validation set? So as I told you, when you are building a predictive analytics model, you first build a model and then validate a model. Like you leave out some of your historic data to validate your model. So if you have data for say a year, you ideally leave out 3 months data to test how good your model has been. So try to apply the developed model on this 3 months held out data. And only when you're satisfied with that can you deploy it in the production environment. And what should be the form of historical data before we can do the predictive analytics? So as I told you, like this comes under the data understanding phase of this game. So you need to understand your data thoroughly, and what are the, so you have to see, okay, this type of analysis is possibly be best done based on say 20 types of data, but in your organization say you have only 5 out of these 20 types of data. So you have to make a decision whether you invest on tools and time to do it, or you would rather spend time collecting more data and then do the analysis. So as SPSS user, how important is it to have statistical background? So there are 2 tools in SPSS primarily. One is the SPSS statistics, which is aimed for people with statistical background. And then there is another tool called SPSS Modeler, which is aimed for people who have no statistical background and only IT background, and they can start using that tool from day one for doing some predictive modeling. And in decision tree, the input is only one. Can we have more input variables? Yes, you can have as many input variables as you want in decision tree or any predictive algorithm per se. In decision tree, how do we determine which nodes would come first while traversing in your slide? So see, in this slide, what I have given is I have given you a view of a decision tree after the model building has taken place. So if you have say 10 different variables to start with, the decision tree algorithm will decide out of these 10 different algorithms, 10 different variables, which variable best divides the set into the different classes that are specified. So if you have say a positive set and negative set, it will see the entropy or the information that is contained on each of these variables. And the variable with the maximum entropy or information will, on that you do the classification first and then go to the next variable. Like that. So you have to go step by step. So there is one variable comes first but also determined by the algorithm itself. You do not have a handle on that. So the next question is, in social data, the influencer is the influencer entity. How will the history data pinpoint the key initiator? No, on historical data you can build up your social network, and then you know now that the initiator has left the service say 3 months back. So that would have some effect. So there is also propagation effect. In the chart that I showed you that okay, if the initiator has left the service or has adopted a new stuff, these direct connections immediately get that effect, but there is also a rate at which the information passes, and that we have to decide in a social network. And only on deciding in the rate can we know, like if you know like word of mouth, if you have a group of 10 people, how long will it take them to get the information on the 10 people? So you have to apply another concept that you have to first estimate that what is the rate at which the information flows in the network, and based on that you can then determine how long the effect would take. So any certifications on Cognos software, so as I told you, you can go to the site ibm.com/certify and you will find all the available IBM certifications there for Cognos, SPSS, and for all the other software. Is predictive analytics only for B2C business? Not at all. Predictive analytics can be for any sort of business, B2B, B2C or B2B. Like you might have like 100 different suppliers from whom you buy different things. So in a B2B scenario, you might decide out of the 100 suppliers who you want to focus on, and if I don't want to do business based on the profit and loss for each one of them. So the main crux of predictive analytics is to break up your business problem So that can be solved using the predictive analytics, and then it can be in either B2B scenario or in a B2C scenario. How frequently does the data tool collect data, and does it happen in real time? Yes, for a real time scenario, it has to collect data in a real time mode only. So how can you please share info how to become a business analytics professional? So I think SAS or Cognos or SAP or all of them are reporting tools. So you understand like how you describe what has already happened in the past to the business for the business need. And then the next thing that you can do is that now based on that you can read up like how can you predict the future. So that comes as the next step. As I told you, the different phases of analytics like descriptive, predictive, prescriptive, web content and simulation. Like there are different phases. So it's always good to start from the first phase, which is very basic in nature, it's a business intelligence step. So the terms predictive analytics and data mining used interchangeably. Yes, they are used actually quite interchangeably, these two terms, predictive analytics and data mining. So I think that brings me to the end of the portion. So if someone else has anything, you can ask me or we'll close the session here. Does IBM provide coaching on Cognos or SPSS software? I am not aware of IBM giving any training itself, but there are a lot of the partner institutions of IBM that does training on that. So what I would suggest you is that you look at the site ibm.com/certify, and you will possibly find a lot of the partners who give training. Also, IBM has a lot of academic initiatives, so tie up with the colleges and universities all over India. So in these colleges and universities, what happens is that they tie up with your faculty, and the faculty is given some training on the IBM tools, and they can then pass on this information to the students. So it either works through some training institute or through the college or university, but IBM directly doesn't do that. What is the common tools available for porting data from data source to the required DI? So I think there are a lot of data warehousing tools and ETL tools available for porting from one data to another data. In the IBM world, there is a range of products under the InfoSphere banner that helps you do that. So in the InfoSphere data stage, quality stage, you can do all these things, but that doesn't come under the predictive analytics, so I will not focus much on that. What are the applications of predictive analytics in social network? So predictive analytics, as I told you, like it helps you to understand like who are the early adopters or churners in a network, or any effects. Say a rumor is there in the network, how soon will it propagate inside the network. So you can do all sorts of this analysis and do the predictions based on that. So there are different types of predictions that you can do along these lines. Yes, Bharat.
Thanks, Mr. Avik, for your informative session on predictive analytics. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. The next session in the Business Intelligence webinar series is happening 1st November 2011 at 3 p.m. Topic for the webinar will be Data Integration Platform versus ETL. We will be having Mr. Somnath Bhadri, Country Head at Informatica, as our guest speaker. So see you all next Monday at 3 p.m. Have a nice day. Thank you.